Atom economy or percentage atom economy is simply one way of measuring how green a chemical reaction is, because what it allows us to do essentially is calculate how many atoms are wasted during a reaction, and they're wasted because they haven't turned up in the desired product. The formula is very straightforward, as you can see here. It's the sum of the molar masses of the desired product divided by the sum of the molar mass of all the products times 100, because we want the answer as a percentage. So let's take a look at a couple of examples. This one is about the extraction of copper from copper oxide using carbon as a reducing agent. So quite clearly, our desired product is the copper, and carbon dioxide, the carbon and the oxygen there are our wasted atoms. So using the formula I just showed you, desired products, so in this case it's 2 moles of copper, divided by all of the atoms, so that's 2 moles of copper plus 1 of carbon dioxide. So let's look at our periodic table. We can find our essential molar masses. Once again, if you're in an exam, use the numbers directly off the periodic table. So for copper, that's 63.5, so 2 times 63.5 divided by 2 times 63.5. plus the molar mass of carbon dioxide, so that's 12 plus 2 16ths, which comes to 44. Multiply that by 100, and the answer comes out to be 74.269. Give your answer to the appropriate number of significant figures. In this case, it's going to be 3, because if we look at the molar masses from periodic table, they're all quoted to 1 decimal place, essentially 3 significant figures. So my final answer would be 74.3%. My second example, that comes from a recent AQA exam paper, I think in this particular example, is a multiple choice. Now, when you're doing multiple choice, you don't have time to work out full calculations of atom economy. You've got to make a fairly quick decision. And they've given us lots and lots of clues in this particular one. So if I have a very quick look at each of these, trying to figure out, just in my head, the approximate mass of the atoms that have been wasted per mole of ethanol. Well, let's start with B. I know straight away that the atom economy of that particular reaction is 100%, because there are no byproducts, there are no wasted atoms. All of the reactant atoms go into our product, so it's clearly not that one. Once again, we are looking for the lowest atom economy, not the highest. Please read the question carefully. If I look at the remaining 3, per mole of ethanol formed, ethanol being the C2H5OH, I've got a carbon dioxide, that's got a molar mass of 44. I've got an ethanoic acid, that's got a molar mass of 60, and I've got an HBr, which has got a molar mass of 80.9. So clearly, my answer is C. It has the lowest atom economy because it has the highest mass, essentially, of atoms wasted. As a side note, it's worth remembering that bromine, for example, has a really high molar mass. So if it is a wasted product, then that's a pretty good example that this particular reaction does not have a high atom economy.